So in this animation, we will discuss the capacitor charging and discharging concept. Firstly, have you ever tried to reason out how to regulate the speed of a ceiling fan, how to tune the radio sets, and how to stabilize the voltage? The answers to all the above question is capacitor. We know capacitor is a passive device that stores energy in its electric field and returns energy to the circuit whenever required. A capacitor consists of two conducting plates separated by an insulating material or dielectric. Now we are discussing the experimental setup. Here we will discuss charging and discharging process. Let's first understand the charging process. We connect the key K to position A. Capacitor is connected to the power supply and current flows through the circuit. Both the plates of the capacitor get the equal and opposite charges, that is plus Q and minus Q, and the potential difference across the capacitor starts to increase while the capacitor is charging. Once the voltage at the terminal of the capacitor is equal to the supplied voltage, then we say voltage supply equal to voltage at the capacitor. When the capacitor is fully charged, the current stops flowing the circuit. This completes the charging phase. Now we will understand the discharging situation. We replace the key K from position A to position B and we see capacitor start discharging. We see bulb will glow with high intensity. The intensity of the bulb and voltage between the capacitor plates drop down gradually to zero, which complete the discharging phase. Now I will discuss the working of the ceiling fan without any capacitor. Now I will discuss here that what will happen to the ceiling fan if I do not attach a capacitor to it. Just a minute. Okay, I will discuss later that single phase induction motor is not capable of self-starting. So, as I switch on the power supply, this fan will not work. But if we give it a push by our hand in any direction, it will keep on rotating in that particular direction. Now I am switching on the fan. We observe that our plates are pulsating but they are not rotating. Now I give the push with my hand. Now we see that fan is rotating in anti-clockwise direction. Although speed is very low. Speed is low because no capacitor inside it. but we observe it is rotating. Now we stop it. We switch off the supply. I can feel the heat. Now if I give it push in opposite direction, after switching on the power supply, I push in opposite direction. That means we can change the direction by just the push. So what are the disadvantages of not using capacitor? Very first, you will say it will be get heated up very soon. Secondly, you will say the speed of rotation of induction motor is decreasing, and you have to apply some extra push. Now I will discuss one more thing with you. What will happen if I connect huge 1000 microfarad capacitor ceiling fan? Suppose I use a huge capacitor to my ceiling fan, then we will see what will happen to it. Now we will switch it on. You can say, and you are observing its speed is very high, very fast it is rotating. You can experience at your home also, but it is not good if you are using a capacitor beyond a limit. It can heat up your fan. Now we will see what happened. All of you just observe what happened, what torture has been done to this fan. You can see it. Now you will see. You can see this heat. So I hope now it is clear to all of you what is the use of the capacitor, and if we use the capacitor more than the value, then what is happened. You see it. So it's just for your knowledge. I hope you got the idea of the capacitor and its use. Now I will discuss the new concept, sharing of charges between isolated conductors. If I say there are two conductors having charge Q1 and Q2, capacity C1 and C2, and there is a switch. If you connect this switch, charge will flow from high potential source to low potential source until the potential of both the spheres, both the conductor becomes same. Suppose I say finally potential of the first conductor is equal to potential of the second conductor, and final charge on this is Q1 final and final charge on this is Q2 final. Then you will say me by the formula Q equal to CV. If potential is same, you can write it Q1 final upon C1 equal to Q2 final upon C2, and you can use the mass identity of junior class. Q1 plus Q2 final must be equal to C1 plus C2, and a charge is conserved. Total charge initially equal to total charge finally. So I can write in this way. Finally, you will calculate final charge on first conductor can be written as C1 upon C1 plus C2 into total initial charge. Similarly, final charge on the second can be written as C2 upon C1 plus C2 into Q1 plus Q2. So these formulas will utilize you next. Okay, principle of a capacitance. Just I am showing the animation, you will get the idea. If I say there are two plates, plate A and plate B. Plate A is given positive charge. As we know, this charge will distributed on both the surfaces. And in front of it, when I put a neutral plate, all of you intelligent, you know that this plate will be get induction process. And what will happen? I think we could not draw there, but all of you know there will be induction process as you bring closer to A. Now, potential due to plate B is not changing because net charge is 0. But when I earth the outer side of the plate B, this positive charge will get neutralized like this. Now, earlier A was having positive charge, B was not having any charge. Now this B is having negative charge. It means potential of A is decreased like this. So now the net potential of the system decrease due to the sum of the positive potential on A and now negative potential on B. It means to increase the potential to the same value as was in the step 2, an additional amount of charge can be given to the plate A. This means capacity of storing charge on A increases. So if somebody asks you what is the principle of a capacitor, you have to say capacitance of a capacitor can be increased by bringing an uncharged earth plate near to it. Before discussing the use of capacitor, again I will say principle. What you will say, let me write here, so you will get idea that if somebody asks you what is the principle of capacitor, you will say capacitance of a capacitor can be increased by bringing an uncharged earthed plate near to it. That we have discussed in the last slide. Now, use of capacitor. Capacitor used a lot. Flash tube, car wiper, pacemaker, and artificial heart pumping. Let me explain you in brief. So, in camera flash which you people use, I am going to explain you basic concept of using the capacitor behind that. Suppose I say this is your flash bulb or tube, and you connect to any battery or cell like this with the help of a key. Now, this battery contains a liquid, and this liquid is having some resistance. I say resistance is R. If I ignore the resistance of this flash tube and connecting wire, the current flow in the circuit can be written as, if V is the voltage of this battery, V by R. But same flash tube, if I connect to the capacitor of same voltage, I say I am connecting to the same voltage capacitor. Capacitor voltage is same, that is V. It means it is having plus Q charge here and minus Q charge here. and this capacitor is getting voltage when I connect to any power supply or battery or cell like this. This is also a voltage V, and we have discussed at steady state voltage of the battery equal to voltage of the capacitor. Now this plus Q charge go to minus Q through the flash tube, and if I calculate the current I equal to V upon, here R tends to 0 because no liquid. If there is a resistance, then a resistance will be negligible. It means when R tends to 0, current tends to very high, maximum or very high. So whenever we require the large current, we have to use the capacitor. But firstly we charge the capacitor by the battery, and then we discharge through the flash tube. So always keep this in mind. Capacitor gives more current, or you can say it gives more power also, because P equal to W by T. At time tends to 0, very fast energy you are utilizing. So power is more, you can say capacitor gives more power. But again capacitor has a problem. As we close the switch, all charges discharge quickly. So again you have to charge it. So now I am telling you some uses we can use in the flash tube, as I told you. Similarly, car wiper, you require again and again energy. In the pacemaker also, it is used in the heart. It gives the pumping. It takes the energy from the battery which is in the pacemaker. Then capacitor takes the energy, capacitor gets the charge, and it discharge. Similarly, artificial heart pumping also it is used. I hope it is clear to you. So all of you just pause the video and read this slide which I have discussed, and similarly pause the video and read this slide also. Now capacitor discharging a photo flash capacitor, I will show you the animation. You will see in this video this flash tube is charged with the capacitor, and as you bring them closer there is discharging like this. Okay. Similarly, there are another application of capacitors, like it is used in microphone. In microphone converts sound wave into electrical signal by changing the D, because later on we discuss the capacitance is given by epsilon naught A by D. D is the distance between the plates. If we change the D, capacitance also decreases. Similarly, when you tune in a radio, we use the variable capacitor. Of course, in television also, when you changes the channel from one star TV to another television network, we will use the capacitor in that circuit. Of course, there is the LC circuit, so we will discuss it later.